Hi, today it's September 4th, and we're doing 2.3 day 2. After we finish 2.3, we're going to review and have a quiz on 2.1 to 2.3, but no notes, so it's like a test on 2.1 to 2.3. So it says, when a function changes from increasing to decreasing or decreasing to increasing, it creates maximums and minimums. When it's increasing and then it starts decreasing, it makes a maximum. Or if it's decreasing and then it starts increasing, then it makes a minimum. Local maximums and minimums. A function f has a local maximum at c if there's an open interval I containing c, so that for all c x not equal to c and I, f of x is less than or equal to f of c. F of c is the highest. We call f of c a local maximum of f. So if we're going to draw a picture, so we have this open interval I, and you pick a point C in it, and this point right here, it's C comma f of c, xy, c comma f of c. F of c is over here. This f of c is greater than any other f of x in this interval. It's the highest point, so it's called a local maximum in that interval. It's a local maximum. A function has a local minimum if there's an open interval I contains c, so that for all x that are not equal to c and I, f of x is greater than equal to f of c. F of c is the lowest. We call f of c a local minimum of f. So if there's an interval and we pick a point c, then this point right here is c comma f of c, and this value right here is f of c. It's the lowest point out of all these x's that are in this interval. The x's have different y values, and the lowest point is f of c. This interval is I. From here to here is I. From here to here, it's I. Example 4. Use a graph to locate the local maxima and local minima. So we're looking for if it goes from decreasing to increasing or increasing to decreasing, where there's a local maximum or local minimum. So here's our graph. At what numbers, if any, does f have a local maximum? So do you see a maximum? Right here in this region, from here to here, this is the highest y value. 2 is the highest y value, so x equals 1. What are the local maxima? F of 1 equals 2. At what numbers does x, if any, have a local minimum? Well, there's a minimum right here. It decreases and then increases. This is the lowest point. So it would be x equals negative 1, and then over here, x equals what? What are the local minimum? F of negative 1 equals 1, and f of 3 equals 0. So where are the local maximum minimum? Those are the x values. What are they? Those are the y values. F of 1 equals 2. F of negative 1 equals 1. f of 3 equals 0. Warning: the y value is the local maximum and minimum. The y value is the local maximum and the minimum, and it occurs at some x value. For the graphs above, we say the local maximum is 2, and that the local maximum occurs at x equals 1. So x equals 1, but the local maximum is 2. It's the y value, and it occurs at an x value. That's how we did those. While it's possible to have multiple local maximums or minimums, because there can be more than one places where it goes up, it could be like mountains, where it goes up in many places, or valleys where it goes down in many places, there's only one absolute or most maximum or minimum. So you can have multiple local maximums and minimums, but there's only one absolute or most maximum or minimum. So let f denote a function defined on some interval I. If there's a number u in I for which f of x is less than or equal to f of u for all x in I, then f of u is the absolute maximum of f. And we say that the absolute maximum of f occurs at u. It's the highest one. All the other f of x's are smaller than f of u. And then if there's a number v in I for which f of x is greater than or equal to f of v, for all x in I, then f of v is the absolute minimum of I, and we say that the absolute minimum of f occurs at v. The absolute maximum and minimum values of a function are sometimes called the extreme values of f on I, or they're the extrema. The extrema means the extreme maximums or minimums. The extreme value. So if you hear extrema, it means what are the maximums and the minimums. So we're going to look at these 4 graphs, and we're going to find the absolute maximum and minimum. We're not doing the local ones right now. We're doing the absolute. So we look at number 1, and we're trying to find the absolute maximum and the absolute minimum. I'm going to pause for a minute. I'll be right back.